Alright, we're going to do a little recap of what we just talked about. So you can write this down. You can kind of make sure you understand what's going to go on for the rest of the year. And kind of begin on what are we going to do for paper 3. So the way I'm going to set it up is that the lessons are going to be Monday, Wednesday, and Friday. Not every Friday, because some Fridays are going to be assessment Friday. The help sessions are going to be Tuesday and Thursday at 8:30 in the morning. That's when your normal class is, so that's what we're going to do it at, so I don't run into any other classes. And then assessments are going to be assigned on Friday, due the following Sunday. There are 6 weeks of school that remain. Within that 6 weeks, I would guess that we are going to do 3 assessments. Maybe 4, but certainly 3. So, for today, the assignment is on Delta Math. We won't have very many assignments on Delta Math because the material that we end up going over is considerably is a little bit higher than what Delta Math has to offer. So we won't, but these 3 things are part of the they're actually things that we went over last year, but they also are things that you know from last year. These are all things that we did last year. We started with, we're going to start with L'Hopital's rule, then we're going to do testing for continuity, and then we're going to do the definition of derivative, and then we're going to finish off with the mean value theorem. All things that are normally on paper 3. That was the material that we hadn't covered before we left. So the first one, L'Hopital's rule. Last year we talked about L'Hopital's rule. Here is L'Hopital's rule. And you can certainly pause the video at any time and write this stuff down and then come back to the explanation. So the first thing about L'Hopital's rule is you got to know that f and g are differentiable. If f and g are differentiable and the limits of each of them individually, the numerator and the denominator individually, either go to 0 or they go to plus or minus infinity. So you get some kind of indeterminate form, 0 over 0 or plus or minus infinity over plus or minus infinity. What then you can do is you can just differentiate the numerator and differentiate the denominator, and you'll generate a new thing to evaluate normally that actually works out. So you really got to kind of figure out, do these limits go to 0 over 0 or plus or minus infinity over plus or minus infinity? These are the indeterminate forms. These are the indeterminate forms that we're looking for. You really never want to say that they're equal to those because they're indeterminate, so you really don't want to say that. You just kind of want to evaluate them off to the side. So, for example, if you have something like this, and you look at that and you go, okay, well, the cosine of pi over 2 is equal to 0, and pi over 2 squared minus pi squared over 4 is equal to 0. Then we're going to need L'Hopital's rule. We can use L'Hopital's rule because suddenly we know that the 2 things evaluated individually are 0 at the value that we're concerned with. So what we're going to do is we're going to take the limit as x goes towards pi over 2, and the derivative of cosine is negative sine. The derivative of x squared is 2x, and the derivative of pi squared over 4 is just 0. So now we have this limit, and these are the exact same limit that we started out with. Well, the great thing now is when we evaluate this one, we're looking at evaluating what's the sine pi over 2 divided by 2 times pi over 2. So if we evaluate this, the sine of pi over 2 is 1, so the top is -1, the bottom is 2, and that is our limit because of L'Hopital's rule. You'll have a few problems on the assignment to do that look like that. So let me back up and show you the whole problem, and then you can copy it down, take a look at it. Okay, so the next example, the next thing we need to talk about is how do you determine if a function is continuous, and how do you do it in a formal way? Remember, the idea behind continuity is no holes, jumps, or asymptotes. So, but what does that look like formally? Formally, what that looks like is the fact that a function is said to be continuous at some x value if all of the following conditions are met. The first one is the limit from the left side, so this is the left side, indicated by that negative next to c, and then is equal to the limit from the right side. And then this is just the function evaluated. And what you need is you really have to determine that these are all the exact same thing. If they're not the same, then the function is not continuous. If they are the same, then you're good. So if you're going to have to show this, formally, that's what you'd have to write out. If you don't write all three of those things out, you might get the idea of, yeah, it's continuous or not, but you haven't formally showed that it's continuous. So what I mean by that is determine if the following function is continuous. So we got a piecewise function here. Got a piecewise function. The top is 13 minus 5x squared when x is less than -2, and -4 plus 3x when x is greater than -2. So here's what we need to do. We kind of need to determine what's the limit as x goes towards -2 from the left side. Well, from the left side, we would be using 13 minus 5x squared. And if we put everything in there, we do 13 minus, this is when you can actually do direct substitution. And if you do that, you get 13 minus 20 or -7. So we've established that from the left side, the limit does exist, and it's -7. We then need to kind of look at, well, what's the limit as x goes towards -2 from the right side? From the right side, we would want to put a -2 right there. And if we look at putting in -2 on that one, then what we happen to have one second, I'm just looking at something. Then what we happen to have is we happen to have limit here, -4 minus 6 or -10. And on this one, f of -2 is undefined. Not only is that not even defined, none of the things are equal. Since none of them are equal, the function is discontinuous when x is equal to -2. So that problem right there kind of shows that you got to actually show all three things. You got to show the limit from the left side, you got to look at the limit from the right side, and then you got to figure out the actual value of the function at the concerning point and see what works. So then we're going to get to the definition of a derivative. Now, the definition of a derivative, when you guys go, if you go to college, when you go there, you'll end up, your professor will end up looking at the definition of a derivative formally. This is really, when we think about what this is this is just the slope. This is just the slope between the point x comma f of x and x plus h, comma f of x plus h. Because that slope would be f of x plus h minus f of x divided by x plus h minus x. If you did y2 minus y1 over x2 minus x1. Now if we make h equal to 0, or make h get closer and closer to 0, essentially we take those 2 points that we have, the first one and the second one, and we squeeze those points together. And by squeezing those points together, we end up generating what is known as the instantaneous rate of change. This is using the definition of a derivative. Well, one of the problems that you're going to have to do today is just to simply write out, what does this limit look like? You don't have to necessarily go about evaluating it, because we get derivative rules that we use to evaluate it, but what would it look like if you just wrote this out? So if we just go back and we just look at that, we're just going to write that same thing out, only now we have a specific function f that is defined. So, if we think about what this is, we'd have, f prime of x is really the limit as h goes to 0, and according to the definition, that's f of x plus h minus f of x over h. Well, if instead of leaving just the notation of the function in there, and we put the actual function that we're given in there, which that should be an h, what we'd have is we would have 5 over x plus h minus 5 over x divided by h. If we go through and evaluate that, we're gonna come up with the value for the actual limit, and subsequently that would generate a rule for the derivative. I'm not making you go through and do that, but just know that that's how you would write out the formal derivative. Okay. So the last thing we're going to cover is the mean value theorem. And we did the mean value theorem last year, and here's what it says, and then we'll draw a picture of it and what it looks like. The mean value theorem says that if f is continuous on a, b, and differentiable on the open interval, so it's continuous on the closed interval, differentiable on the open interval, then there exists at least one value c on the closed interval such that the derivative is equal to the slope. So remember last year we talked about this being the derivative is equal to the slope. The instantaneous rate of change is equal to the average rate of change. So that's what the mean value theorem is saying. The mean value theorem, if you were to draw the mean value theorem out, be the kind of thing where if we were given some function that looked like this or something, and we were given a couple of points in here, maybe this point right here, and maybe this point right here, and we were to look at the line that goes between those 2 points, and we're going to look at the slope of that line. There is some line on this graph such that we're going to consider this to be touching right there, such that this derivative is equal to, if we call this A and this B, the slope of this red line, f of B minus f of A divided by B minus A, that those two things right there are equal. So the kind of thing that we look at is coming up with some sort of an equation. Might be something like this. Hold on a second. Something like this here. I'll write an example out. So maybe the example is you got this function f of x is equal to x cubed minus 14x squared plus 56x minus 69, and you want to find all the values where f prime c is equal to the slope between points when x equals 1 and 4. So the idea behind that is going, okay, well, let's try to figure out what we got here. Well, if we do f of 1, if we go back there and we do 1 cubed minus 14 times 1 squared plus 56 times 1 minus 69, we'll find out that that's negative 26. And if we find f of 4, if we go through and plug 4 in there, we'll find out that that's negative 5. So, and you can go through that calculations and calculate it, but what we're doing now then is we're going to say, okay, well, so f prime of x, using the rules that we have for differentiation, 3x squared minus 28x plus 56, that right there, that derivative has to equal negative 5 minus negative 26 divided by 4 minus 1. So if we go through this, we know that you can do that calculation. That turns out to be 7. But we know that 3x squared minus 28x plus 56 has to equal 7. And then you just go through and solve this using algebra. You all should be able to use algebra on there. Come up with, there should be 2 values. If you did that, if you went through and solved this, you can do that on your own. What you'll find out is x can equal 7 divided by 3, or x can equal 7. You go through and solve that. So this is our only answer. Because this one is out of our interval. So we can't use it. It's out of our interval. We can't use it. Hopefully this is helpful, and you're all set. Thanks.